we're going to do a little bit of factoring and review some of that so that we can use factoring to solve some larger polynomials later on. So first one's type of factoring that we deal with. Remember, our rules of factoring are: one, to make sure it's in descending order. Number two, the first thing you look for is the GCF. After you've done the GCF, you're going to count the terms, and that tells us what method to use out of to either differences of squares, sum is differences of cubes. If it's 2 terms, 3 terms is a trinomial, so we'll use that X method. Excuse me. And then the 4 terms, we're going to use grouping to help that with that. So let's work our way through some of these, and maybe we'll jog our memory on how to factor some things. So first little set here is on GCF. So 12a to the third plus 10a squared. 12 and 10 are both divisible by 2, so 2 is the largest number that goes into both of those. A squared is what both of them share. That leaves 2 times what is 12, it'd be 6. We use 2 of the a's outside, so I have 1 left over there. 2 times what is 10, that's 5. I used both of the a squares on the outside. So there's the factored form for number 1. Number 2, 14 and 7 have 7 in common. Now we need to look at how many m's they have in common. There are 8 here and 2 here, so they have 2 in common. It's always going to be the smallest set of those. And there are 5 n's and 2 n's here, so there are 2 n's in common. All right, and then 14 is 7 times 2. Take 2 of the m's away from m to the 8th, you got m to the 6th. 2 of them from m to the 3rd minus 1. And there's the factored form for number 2. All right, differences of squares are what we're going to talk about here. And when we're looking for differences of squares, remember it's got to have 2 terms with a minus sign in the middle and square things in there. And the square numbers, perfect squares, are like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and keep going forever there to that. So you're looking for numbers like that to be a perfect square, to be differences of squares. And the way differences of squares works, you can rewrite it as something squared minus something squared. Then the factors are real quick and easy. One's a plus and one's a minus, but the terms are the same. Okay, so still want to look for GCF if there is one before we do any differences of squares. So we still got to look for that first. So let's look at number 3 here. 9 and 49 don't have anything in common, but I can rewrite this as 3x squared, and this is 7y squared. So the factored form is going to be 3x plus 7y, 3x minus 7y. And there's the factored form for that. We look at number 4 just across here. We have 72c to the 4th minus 2. Those have a GCF of a 2. We'll factor out a 2. It's going to leave me 36 c to the 4th minus 1. And 1 is a square number and 36 is a square number. So that means I can rewrite that as 6c squared squared and 1 squared. So c squared squared comes from the c to the 4th. And so the factored form for the final answer here is going to be the 2 that we factored out at the beginning, and then 6c squared plus 1, 6c squared minus 1. There's the final answer for number 4. All right. Number 5, got more letters in there, so we got to look and see about GCF and all that stuff. So 7 and 28 have 7 in common, so there's going to be a GCF. They both have m's. They have 1 in common. N, they have 1 in common. Leaving in parentheses m to the 6th minus 4 n squared, which can be written as a difference of squares. That's m to the 3rd squared minus 2n squared. And so the factored form for number 5 is going to be 7mn m cubed plus 2n n cubed minus 2n. And then number 6, 10w is the GCF. That's going to leave us w to the 4th minus 1. This one's going to be a little bit fancy because some things that are going to happen here. Again, difference of squares. So that's 10w, then w squared plus 1, w squared minus 1. What we've got here is this part here is a difference of squares itself. So it'll factor a little bit further as w plus 1 and w minus 1. So this is going to be final answer 10w, w squared plus 1, w plus 1, w minus 1. And there we have the factored form for number 6. Okay. All right. Next, in the two terms part of factoring is the sum of cubes. And the sum of cubes uses perfect cube numbers, so cubic numbers. 1 to the third power is 1, 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is 64, 5 to the third power is 125, 6 is 216, 7 cubed is 343, 8 cubed is 512, and you could keep going forever there. So they get pretty large pretty quickly. But the rule for a sum of cubes is if you can rewrite, it is a cubed plus b cubed. So you rewrite it as something cubed plus something else cubed. You got a short factor, a plus b, and a long factor, a squared minus ab, which is the product of the two things that you have, plus b squared. So let's get our sum of cubes here. So this one is just a simple sum of cubes. It's x cubed plus 3 cubed. So that means we got a short factor, x plus 3. The short factor is always the same. So a plus b, in our case, a is x, b is 3. So that's going to be x plus 3. The long factor, you used up one of the x's, so you got 2 left. So x squared goes there. X times 3 be 3x. And it's always the opposite sign in the middle of the long factor. So if it's a sum here, we're going to use a minus. And then we used up one of the 3's in the front, so we got 2 left. That'd be 3 squared, which would be 9. And there's the factored form for that sum of cubes. All right, let's look at number 8. So here we have 2 letters. We got a m cubed and then 216 n cubed. I think I can rewrite that as m to the third plus 216 is 6 to the third with an n on it. So then again, we're going to have a short factor, m plus 6n. The long factor is going to start with m squared minus 6mn. So you just multiply m times 6n plus, and then we're going to square 6n. So 6 squared would be 6 times 6 is 36 n squared. All right, let's look at number 9. Again, we always have to keep in mind that there could be a GCF, and in this case there is. 4 goes into both of these. So I'm going to factor out a 4 first. 4 goes into 500 125 times, into itself once. And then I can rewrite that as 5a cubed plus 1 cubed. So when I go to factor that, I got the 4 that I pulled out at the beginning, then the sum of the two things that are cubed, so 5a plus 1. And then here we're going to square 5a, which would be 25a squared, minus 5 times 1 is 5a. And then we're going to square 1. 1 squared is 1. And there is the factored form for number 9. Look at number 10. We got several letters in there. Look for a GCF. 24 and 375. 24 is divisible by 3 because 2 plus 4 is 6, and that's divisible by 3. 3 plus 7 is 10, plus 5 is 15, and that's divisible by 3. So I know 3 goes into both of those, and they both have C's and D's. So 3 CD, I believe it's 8 C to the third plus 125 D to the third. And we could rewrite that as 2C cubed plus 5D cubed. And then we can do our factoring. So we have 3CD, GCF we pulled out at the beginning, 2C plus 5D. Now the long factor. Squaring 2C would be 4C squared minus 5 times 2 is 10. C times D is CD. And then plus 25D squared. Long one on that one. A lot of stuff. So the sum of cubes is done that way. So the next one is the difference of cubes, which is similar rule. Something cubed minus something else cubed. And then you got a pattern again. So we got A minus B this time. The short factor is the same sign. It's both. On the sum of cubes, it was a plus. On the difference of cubes, it's a minus. And then on the long factor, squared. And then it's the opposite in the middle, which is plus. Product of the two things. And then always plus on the last term. Let's look at building some differences of cubes here with this one. X cubed minus 1. This is a simple one to start off with. So that's going to be x to the third minus 1 to the third. So A and B. A is x. B is 1. So our short-term factor is going to be x minus 1. Our long factor is going to be x squared plus 1 times x is x plus 1 squared is 1. And there's our factored form for this one. Okay. Number 12, 216 is a cubic number. We know that already. It's 6 cubed. So we're going to use that to rewrite this as 6k to the third minus 5 to the third. Again, short factor is going to be the same sign. So 6k minus 5. Long factor is going to be 36k squared plus 6 times 5 is 30k plus 25. It really is just learning this pattern to do sums and differences of cubes. Let's do number 13. 13 is not in the right order, so I'm going to factor out a negative 4 because that's the GCF is 4. I want it in descending order, so that's going to give me 8 h to the third minus 1, which is much easier to factor. 3h cubed minus 1 cubed. So again, we got the negative 4, we got 3h minus 1, we got 9h squared plus 3h plus 1. And there's our factored form. Number 14, GCF of a 2. And then we got x cubed minus 27 y cubed, which is x to the third minus 3y third. We got the 2, x minus 3y, x squared plus 3xy plus 9y squared. All right, let's get into trinomials. Remember trinomials, it's the x method that we use to get there. Makes it easier to do. And so here we have a trinomial. It's not x squared in plain x, but it works the same way because this is twice as big as that, not n to the fourth and n squared. So can you still use the x method for this? We need to multiply to be negative 24 and add to be 2, be 6 and negative 4. and there's nothing in front of the end of the fourth, so we can take the shortcut and use n squareds to get our factors out of this. If there were a number there, we'll have to use the grouping stuff. We'll get to one like that eventually. And then we look at each of those pieces and see if they'll factor further. I know that this is a difference of squares, so I'm going to factor it as n plus 2 and n minus 2. So n squared plus 6, n plus 2, n minus 2. And there's our factored form for number 15. Let's go over here to number 16. We have w cubed plus w squared minus 20w. They have a GCF of w. And now I can do the x method on that. We need to multiply to be negative 20 and add to be 1, 5 and negative 4. And again, I can take the shortcut there, w, and then w plus 5, w minus 4. Those won't factor any further because they don't have a squared or anything on the w, so you know you're done there. Okay, let's look at number 17. 17, we have 2a cubed plus 38a squared plus 68a, and we want to factor that. So I'm going to use GCF first because they're all even and they all have a's. So 2a, and then leave us a squared plus 19a plus 34. And then I'm going to do x method on that. So multiply to be 34, add to be 19, 17 and 2. And again, I can use my shortcut, a plus 17, a plus 2. At number 18, we have a GCF of x. That's x to the fourth minus 24x squared minus 25. And that will factor using the x method. Multiply to be negative 25, add to be negative 24. It'll be negative 25 and 1. And I can use the shortcut here because it's x squared plus 1, x squared minus 25. Again, because we have x, whatever the middle term is what's going to be the front variable on the shortcut. Here, this one will factor as a difference of squares. So we're going to go one more step here. X squared plus 1, x plus 5, x minus 5. Factored form for that one. Number 19 here. And so this one is a trinomial. There is no GCF, but it has x to the fourth and x squared, so that means we can do x method. I'm going to multiply 3 times negative 5 to get negative 15. It's got to add to be 14. So that'd be 15 and negative 1. But I can't take my shortcut here. I've got to go the long route. So I'm going to put in negative 1x squared and plus 15x squared minus 5, and I'm going to group those. It's going to be x squared, 3x squared minus 1, and then this one's going to be plus 5x, or no x's, just plus 5, and then that'll be 3x minus 1, 3x squared minus 1. So my factors are 3x squared minus 1, x squared plus 5. Neither of those will factor any further because this is not a difference of squares because 3 is not a square number. This is not a difference of squares because 5 is not a square number. It's not a minus sign in the middle either. Okay, so that was factor as far as we go. Let's look at number 20, another trinomial that we could do. No GCF between 9, 12, and 4. So 9 times 4 is 36. And it's going to add to be negative 12. So it'll be negative 6 and negative 6. And again, I'm going to go through the grouping step here. Group the first two together. Their GCF is 3m squared, leaving 3m squared minus 2. And then this GCF will be a minus 2. 3m squared minus 2 in parentheses. Final answer, 3m squared minus 2. And then another 3m squared minus 2. And there's the factored form of that trinomial. Okay, they won't factor any further because those are not square numbers. Let's look at 4 terms. 4 terms we use grouping. Group the first 2 terms together, and the last 2 terms. Factor the GCF out of each group. So for this example, we factor out x squared and leave us x plus 1. We factor out a negative 4 and leave us x plus 1. And then the factor it's the same as x plus 1 and x squared minus 4. But x squared minus 4 factors a little further, so we actually need to change that into x plus 2, plus 2, x minus 2 is the factored form for that. So I always got to look for that little extra step of factoring if it exists in there. So let's look at 21 through 24 real quick. 21, group the first 2, last 2, so that's going to be x squared, x minus 1, plus 9, x minus 1, x squared plus 9, x minus 1, and that won't factor any further because that's not a minus sign in it. Okay. And then let's do the second one. K squared, k plus 5, negative 1, k plus 5. So we have k plus 5, and then k squared minus 1. K squared minus 1 is the difference of squares. So I'm going to factor it one more time. K plus 5, k plus 1, k minus 1. Look at 23. GCF across the whole problem doesn't exist, so we group v squared, 4v minus 5, minus, let's see, 4 goes into both of those, so it'll be 4v minus 5. So we have 4v minus 5 and v squared minus 4. Again, this is a difference of squares. V plus 2, v minus 2. There's our factored form. All right, 24. Last one here in the notes. First pair is going to have a GCF of 2x to the 4th, even x minus 9. And the second pair is 7x minus 9, or 2x to the 4th, 7 x minus 9. Again, very important. Remember your rules. Descending order first. GCF, count the terms. 2 terms is either a difference of squares or a sum or difference of cubes. 3 terms, we're going to use the X method. 4 terms, we're going to group. And that is factoring polynomials.